Well, good afternoon, everyone. Thanks for joining us today. We apologize for the brief technical difficulties that we were navigating through, but they're now solved. My name is George Smith. I serve as the Director of Michigan State University Ag Bio Research and Senior Associate Dean for Research for the College of Agriculture and Natural Resources. And I have the great pleasure of providing a little bit of background about this webinar series and introducing our two speakers today. So to kind of set the context for this, for those of you that aren't aware, we've been undergoing a strategic planning process at Michigan State University for really several years, starting before the pandemic, to envision what we can do to help support the dairy industry, being impactful at the state of Michigan, nationally relevant, and also influential at the international level. And through a whole series of conversations and the efforts of many of our faculty, and you're going to hear from one of the leaders of this effort today, Dr. Wei Liao, we developed a vision for the future, and we were very fortunate. And this vision was developed in collaboration with our stakeholders in the dairy industry in the state. We were very fortunate that the entire agriculture community came together and went to the state of Michigan requesting a capital investment to help us build a new dairy facility, to expand the scope, depth, and reach of our impact for dairy producers in the state, to support the number one contributor to the ag economy, and help develop a sustainable future for the dairy industry in the state and beyond. So we hosted a on-campus think tank here, I believe in the spring of perhaps last year. Got a very strong response to that. And so what we're trying to do is build enthusiasm and talk further about the programmatic vision for this new facility and the transformational impact that we think it'll have from a sustainability perspective, from creating a circular agricultural dairy economy, and from training the workforce of the future. And so this is the second of 3 webinars we're hosting in the spring that will culminate with an on-campus event on May 7th. And if there are folks on the webinar who haven't received this announcement yet, to save the date, you will be receiving it shortly. So, and again, one of the key programmatic goals of this whole new endeavor was to help work with our dairy industry to create new sources of revenue from dairy waste and to create a more sustainable path forward for our dairy industry. And we have 2 fantastic speakers here today, which are going to share their insights and thoughts on the process and challenges and opportunities for the future. Our first speaker is Dr. Wei Liao. He's the director of the MSU Anaerobic Digestion Research and Education Center at MSU. I've really enjoyed working with Wei on this effort. He's incredibly motivated, incredibly enthusiastic, and he foresees a future for this facility to really do cutting-edge research that's going to make a difference here in the state of Michigan and beyond. Dr. Liao leads an active research program on biological conversion of agricultural residues into bioenergy chemical projects. His primary research areas include self-sustaining waste utilization systems, integrated farm-based biorefining, and improving energy efficiency for small-scale animal manure management systems. And you're going to hear about the vision for this test bed facility in Dr. Liao's remarks. And our second speaker is Holly Bowers, who is Vice President of Gas Engineering and Supply at Consumers Energy. I'm also happy to announce that Holly is a proud alum of the College of Agriculture and Natural Resources and the Department of Biosystems and Agriculture Engineering. We've really enjoyed our interactions with Consumers Energy from the very beginning of this effort, and your support has been really influential in helping us craft that vision and secure support from the state of Michigan for this new vision for the future. Holly has over 25 years experience leading the company's natural gas transmission, distribution, and supply operations. Holly's held several key roles at Consumers Energy, including Executive Director of Operations, Compliance and Controls, and Executive Director of Gas Asset Management. And so with that, I'm going to turn it over to our speakers, and we look forward to the conversation today.
Thank you very much, George, for the introduction. So again, my name is Wei Liao, and Holly Bowers and I are going to present this the manure utilization section. Actually, we are developing this public and private collaboration to really develop and implement innovation solutions to help their industry actually to address, our grand challenges they are facing at this moment. So. And again, we are focusing on, hold on, let me kind of get into my slides. We are focusing on our dairy industry, like previous, webinars, and many of you attend. Dr. Bradford and Jose from the Elenca talk about, so our dairy. Just give again brief, introduction about, dairy farms, dairy industry in the United States. If you look at, the whole, nation, we have more than 24,000 dairy farms in the United States, and total, numbers of, the animals, more than, 9 million. And with those, the animal, numbers, if you look at, the across countries, actually it's wide, the range in terms of farms size. On the west side, there's some big farms there, and average, the herds performs is a bit bigger than the rest of the country. And this gives us some of the data and base and how diversified this the dairy industry is. So the solutions we develop is not going to be kind of one the top of the shoes fit all the farms. We need to have to develop different the systems, different the technology to satisfy the demand from the different the communities, the different the dairy farms. So with that being said, if the look at the dairy industries, actually this is a trend in past several decades, and we need to thank all those animal scientists, the vet scientists, the engineers actually really enhance our the dairy productivities. And our numbers, their herd numbers from the later 50s to now simply dropped, but our milk productivity have been increased. And of course, the with the increase of the milk production and our the feed strategies and of course the manure production are correspondingly changed. And if you look at this chart, we show the dry matter intake is like animal feed significantly increased too, and correspondingly our the manure per dairy cattle also significantly increased from of the later the 50s 5 the kilograms per cow and getting up to 8.5 10 kilograms dry manures because we're focusing on the dairy manures, so we just pull these numbers out and take a deep look at that. So current challenges because of the you see the dairy manures numbers there, and in terms of their farms handling this manure management, the practices. And current, typical practices for dairy farms are lagoon storage, then land applications. And with no matter how big the farms are, some large keyfolds operation, some of small family the operations. Still, we have a large quantity. That's a natural of rumen systems and dairy systems, organic wastes, manures, and the urine and other the feed, the waste, and some of bedding materials. And then the potential nutrient load and the groundwater contamination and odors is kind of, so a lot of communities and experience that, so odor, the situation and the methane emission, air pollution, and of course, something related to public health and equity. And look at the manures. Manures can once we talk about manure or talk about animal waste, people always think about okay negative things more than the positive things. The positive side is okay, this is fertilizer we can use back to the land. But on the other end, just mentioned earlier, all this odor and groundwater contamination, nutrient runoffs, all those things are the negative aspects. But if you look at it from the engineering aspects, and Holly and I both are engineers, so we love numbers. So we typically extract information from numbers. And if you look at our their feet from the different angles, think about this manure streams. And 30% carbon. Yeah, a lot of carbons get into the dairies and respiration, the energy to produce milk and to their daily activities. And only 20% of carbon directly from the feed getting to the milk. 30% of them ends up in the manure. Actually, more carbons in manure than the milk we consume. And then if you look at other, the major, the elements, nutrient streams, nitrogen, phosphorus, potassium, actually you can see that, ratios. We more, that those, compounds are in the manure than, the milk. So this kind of, the numbers, and many for you, many for us know those. But another thing is I really want to everybody focus on these two numbers, the concentration of those, the elements in the feed and the concentration of those elements in the manures. Actually, our dairy cow, from other angles, once they produce milk, actually, they are concentrating those nutrient compounds in like nitrogen, phosphorus, potassium. You can see the concentration increase. If you start from another angle, don't consider okay, those waste streams. Just considering the dairy cow or the rumen systems as a reactor, actually it is concentrating some very valuable nutrients. First of all, they can generate quite a bit of nutrients coming there, and second of all, actually they're concentrating those things for us to develop solutions to utilize that. So that's kind of the baseline for this whole manure innovation or manure utilization, the perspectives that we light on. Okay, then we kind of look at the details, carbon, nitrogen, and phosphorus, three big, the elements in manure. First, look at the carbon. Actually, total dry manures from this 9.3 million, cattle we have in the United States. We are looking at 29 million metric tons of manure, huge amount of manure. And this biogenic carbon, actually later on, Mr. Bowers will mention about this whole, the renewable natural gas, the carbon intensity thing. And actually, there's the 11 million metric tons carbon can be used to replace some of the carbon intensive, carbon from some carbon intensive operations. Another thing that I really want to emphasize the manures, actually through our dairy system, rumen systems, in that manures are reaching the microbial communities. There are more than 6,000 different microbials in the systems that synergistically digest, some carbon, nitrogen, phosphorus into value-added products. Methane is one of them. And look at that, all these aspects, just to look at, the carbon utilization from for example, anaerobic digestion perspective. If you just look at the dairy industry, yeah, we just contribute a little bit, 0.8% of, the total natural gas, the production, if you look at the entire, the country's demand. And but again, as mentioned, if you look at those carbon, biogenic carbon, and look at these, microbials, they can provide a seed and a base to receive other the carbon-rich materials, for example, agricultural residues, corn storage, and all those, the soybean residues, all those things. Actually, the gas production potential simply increased to the 13%. And once getting to 13%, 13.2%, and it's a big chunk piece of carbon, the base of fuels renewable fuels we can produce to replace the fossil-based, whatever you messing or and other, the fuels. This is very good, the numbers we need to remember, pay attention later on. We talk about the potential. And then the same thing with the nutrient streams. If you think about it, we recover all those, nutrients from their minerals. 14% of national demand in the United States can be covered, and 17% of phosphorus, 28% of potassium. Okay, with that being said, so then look back, the manures, the dairy manures. How could you use them? This is from the EPA X-Star. They draw this beautiful, the cartoon. If you look at, the dairy manure utilization technologies, one of the key technologies we are developing is anaerobic digestion. Anaerobic digestion is straightforward. I'm not saying the simple. It still requires certain of technique, the inputs on that part, but it's very, very straightforward. We don't need to do much of the manure pre-treatment handling things. You can put in the systems and adjust temperature and maintain the anaerobic conditions, maintain the retention time, and it can generate a very valuable, methane gas on one end. And of course, during that process, there's some other microbials actually really turn nutrient on the nitrogen part into the ammonia, phosphorus, into the oxidative phosphorus, and some soluble phosphorus can be used as, the fertilizer. That's the anaerobic digestion process. Then kind of jumping to the anaerobic digestion the process. There are two major, streams. One is gas streams, actually biogas we call that, and containing and 50-70% of the methane. This is very, very valuable. Actually, through this process, current the biogas utilizations, we're talking about electricity. It can generate electricity and heat, and the electricity can be used for the EVs, electric vehicle charging. And on the other end, and Mrs. Bowers will emphasize on this renewable natural gas, pipeline quality, and vehicle fuels, even as feedstock for the chemical productions for the chemical industry. That's current biogas utilization technologies. And on the digestate part, liquid digestate, we do liquid solid separation, and solid digestate actually have the suite of the applications from the fertilizer, soil amendment, and some of facility using the dryers and the remove all the pathogens, send back to the feedlot as animal bedding, and there are some of other use as construction materials and other potty soil horticulture products. But for liquid part, at this moment, we have limited applications and very much the land applied on for the cropland and for some other, liquid application. There's some of, the discussion on this piece, particularly for this K-Force operation, because concentrate, the land, we have a lot of animals in terms of, land requirement for this land application. And there's some of the discussion on that piece. We're talking about actually, we're focusing on the liquid digest piece, new solutions, new technologies, actually we can extract more values out of this liquid digestate. And then look at the entire nation, and look at this EPA XSTAR did a pretty good job so for to map out this whole digest in the United States. And we focus on a little bit more on the dairy, the industry. If you look at California and West Side, Washington, Idaho, particular, there's some large farms in our regions, in Michigan regions, in Indiana, we have a couple of pretty big farms and build digesters. But overall, actually, if you look at the entire nations, only 2,400 digesters, and considering all these the landfill and agriculture operation, municipalities operations, not a whole lot. And if you look at Germany's alone, agriculture sectors, 9,000 dairy farms, you can see the potential on this land in our nation and what kind of biogas production we can expect in next couple of years. And back to the dairy farms right now. So we in past 4 or 5 years, numbers increased quite a bit, but we still only have the 400 digesters from the dairy industry of dairy farms. And then look at this current the situation in the United States. But if you look at potential economic environment benefits, again, we emphasize, particularly in MSUs, as a group of the scientists, engineers work together. We believe, the environmental sustainability without economic sustainability is not going to be sustainable. So environmental sustainability, economic sustainability must go along side by side. So this is why kind of I put the sum of the numbers, greenhouse gas emission reduction, and considering, the manures, considering entire U.S. agriculture, 10% of, them. If, so we handle the methane, handle manure in a, positive way, in a, effective ways, we can remove 67, 80% of those emissions. And soil water pollution is a big thing. And again, nutrient recovery, this is what our focus at MSU. And actually, we really can remove 95% of the nitrogen phosphorus. Later on, you will see some technology we're developing out of this, the streams. Not only just to remove, to treat them, actually we utilize them, turn them into the solid fertilizer, sell them on the market, and actually bring the revenues back to the rural communities. Again, the revenue generation and the Mr. Bowers talk a little bit more on this, renewable natural gas and carbon credit things, carbon intensities, and those things are, the revenues can be returned back to, the rural communities. The market grows, this is some numbers, statistic numbers, 1.2 billion in 2024, and we're expecting 6% of an increase through the entire through the next 10 years. And then another thing is very, very important. Dairy industry plays a pivotal roles in this whole circular economy integration. As I mentioned earlier, manures are actually not only just rich in phosphorus, nitrogen, and potassium. There's some other very unique, the microbial system in there. They can be the inoculant or seed to boost other, agricultural resource utilization. As I mentioned earlier, 13% of the natural gas production in the United States can be produced using manure as seed, along with other, the agricultural resources. The next, the dairy farms operations like corn store, those things. So this is a large piece. This is some technology later on you see we're developing. And okay, then talk about this all the good things about the manures and the digestion. Where we are right now. Actually, this is a kind of from technology perspectives. If you see the carbon, nitrogen, and phosphorus, three big nutrient elements in the dairy manures. If you look at efficiency, I'm engineers. The Mr. Bauer's engineers. Efficiency is the number one thing if you want to kind of improve the whatever systems in performance. And if you can look at the carbons, 60% of the carbon in the biogas based on current digestion technologies, but there's a lot of carbon dioxide in there. It's not only just methane, and 40% carbon still remain in the digester. In that 40%, at least another 20-30% are bioavailable, biodegradable, can be used for the biogas production. We're not there. We need to kind of improve that. And if you look at nitrogen, only 50% nitrogen, which is already pretty good, turned into the ammonia, but other 50% still remain in this urea or the protein form. If you really want to extract the value out of this nitrogen forms, we need a higher ammonia concentration in there, and we can apply different technology on that. Same thing with the phosphorus. You see, the conversion efficiencies are the most important parameters we need to improve. And then we will have a much better economic and engineering performances on all those, the dairy manures, and along with other, the feedstock, we can do the co-digestion systems. Stay. Okay, this is kind of our next part that lead to, our innovation solution piece. And this is our, vision. And high efficiency, zero discharging, zero emission dairy manure management, dairy manure utilization systems. And RNG part for the renewable energy and all those, carbon utilization technology, including plasma. Later on, you'll see we're developing. And liquid part, again, we're developing more efficient utilization systems, and different from stripping, different some other technologies. Of course, different size farm with different technologies. Really develop, to produce solid fertilizers and generate clean water. And we want to reclaim the water, we can discharge them. And really satisfy this, our manure management is a portion of this circular agricultural economy and play very important roles because of the, at the end, all the residues can be recycling and value add product back into these loops and back into our rural communities. So with that being said, this is why MSU's effort, being 16 years, a group of engineering scientists start 2009, including me and a couple other colleagues, we established ADREC, Anaerobic Digestion Research Education Center. It's first of this kind in the nation, and have the capacity from of the bench scale, the fundamental capacities, microbial ecology, genetic work, all the way to the demonstration scale. And this is back that we want to set up this way to really kind of boost this the private and public the collaboration, the partnership that matters to push the entire with utilization technology to next levels. So along that lines, 2010 we built this the 250,000 gallons of plug flow, and then in 2013 built a little bit larger 500,000 gallons of the CSTR with the electricity generation, and then move on. We focus a little bit more on the carbon, improve carbon efficiency We study algae and other, the technologies to really turn carbon dioxide in the biogas and flue gas, other, power in the industry into some value-add products. Start from 2019, we really can deep dive into these, nutrient recoveries. And we built a facility on campus, a pilot facility with some solar, talk about solar later on. And solar is the intermittent the energy source. We use that for the nutrient recovery. For those, process doesn't require continuous power, supply. So because we don't want to use a battery and the large, energy storage there, so can do that, so once, the sun shining out of there. And then kind of, the last year we started because and many of you know, we have the new dairy farms coming online this year. So we are kind of in the stage to upgrade our, current digest operation and to satisfy our new need and also satisfy some of the implementations for new technology. So this kind of our timeline for, the ADRAC. And this are our missions. Again, we want to create a platform for the multidisciplinary, multi-institution, national collaboration to develop this, sustainable, again, environmental sustainable and economic sustainable solutions for the industry, for agriculture. This is our facility, and we have high bay area here. Just give you a few examples of what we're doing right now. And again, next generation high efficiency. Efficiency is the key word I mentioned a couple of times today. And really develop anaerobic digestion, we call the systems. And energy utilization, like consumers' energy, Dr. Bowers will talk about their, the effort and to upgrade this, the natural gas or renewable natural gas matter. And for ours, we also really focus on this, nutrient stuff. Again, solid NPK products. That's our target, extract out of, the digestate and the clean water. And then this is kind of the map, some detailed, and just using one or two slides, mention a little bit about technology. One of them, remember I mentioned, manure could be used as a base, not only just a cow digestion with the food waste. Actually, there's a much bigger in volume of the agriculture as corn stover, those things. And however, those corn stovers and the agriculture residue, they are pretty dry. They're sometimes, there's not, in the liquid form. And there's the situations how can we mix them with manures. So we are intensively working with some of the enzyme companies and developing a simple and high efficient one step for pretreatment steps. Really can extract carbohydrate, enhance lignocellulosic based, enhance of the digestion, digestibilities, and then kind of particularly for the small medium farm, makes that scale reach the level consumers' energy or the other utility companies can jump in to do their renewable natural gas upgrading scale, reach the level, make economic sense. That's kind of the effort on that piece. And another end, the part, this is the front end for the feedstock part. At the back end, and once we do this, renewable natural gas upgrading, and we get a methane gas produced, then we have quite a bit, carbon dioxide. And how could we take advantage of those carbon? Those carbon is still valuable. So this is some technology on campus we're developing. A simple stage, low temperature plasma. Actually, we turn these, the gaseous compounds into liquid, bicarbonic acid. And then we open up the door for the rural communities to provide intermittent for the entire chemical industry, bulk chemical productions. And the PETs or the plastic industry that actually can benefit from of this, liquid methane based, the chemical for, the entire, the plastic industry. And that's just on carbon side. And look at the liquid the digest stage. Actually, we are developing again. This time, so we use this intermittent solar energies because we don't need to run that 24/7. And you then develop a high efficiency, low energy, very different from the typical stripping those technologies, electrocoagulation, electrodialysis, and really recovery ammonia, not ammonia sulfate, not ammonia compounds, ammonia itself, and use that as green ammonia fuels, or they use it as the intermittent to produce fertilizer. Same thing, the phosphor-rich solid fertilizer, and really kind of makes this a liquid. At the same time, because electric coagulation, electrolysis process, we actually clean up the water. The water, our target is a discharging standard, satisfy EP discharging standards. So then next level, no matter how big in dairy operation, digest operation, for operation use, actually you do not have that concerns regarding land demand for the digest the applications, land application. You literally just treat all those the water and get them cleaned up enough. You can clean up them enough and then discharge locally. And you can see this kind of our, the current pilot scale system, we can really clean up the water. And of course, we need to scale them up to study that a little bit large, like our pilot facility on campus demonstration facilities. Next steps we're moving towards. All those pictures are pilot scales operations, and we are running past couple of years. Okay, with that being said, just give you a few examples. We do a lot of time limitations, and then Dr. Bowers can talk about, Mrs. Bowers give you another talks about consumer end stuff. I just want to use one more slide to show our vision and for future, dairy operations, what it should look like. And it should generate more than 32 billion cubic meters of this methane per year. This is very conservative. I'm not kind of considering the further increase efficiency. We take the medium, the numbers of efficiency increase at that level. What that means, actually, the entire dairy industry and can power entire nation space programs. And I just give you the numbers. This is what we are doing. Some of very interesting analysis, and look at all these Mars, projects like last year's alone. And NASA and other couple of companies the kind of put a lot rockets to the space to the space to some other the space the launch is only like 150, and 5,425 Mars round trips of this the space the launch rockets can be powered by the entire dairy industry. So which means that dairy, we can use a cow to power all those rockets that develop all those kind of, the Mars program or the other space programs. At the same time, we can power more than 40% of, the current semi trucks if it turns them into the RNG powered trucks in the nation. It's pretty big numbers. And then actually we can satisfy entire biochemistry industry just from of our dairy farm and with surrounding, the agriculture residues, and to get all those PVC and all those the plastic and other chemical production from that, then offset 10% of U.S. greenhouse gas emission, and again the NPK numbers satisfy chunk piece of the nutrient demand. So this we are the heading towards, and all the technologies, the MSU taking lead and working with the other universities in the nation and working with our partners, utility companies. Yes. So that's kind of our strategies of moving towards that direction, advancing innovations, build the capacity, and another things very important. We need to build these partnerships with the rural community, with utility company, really kind of drives this local global impacts and about waste utilization. So talk about partnership. I pass this to the Mr. Bowers talk about the consumers industry perspectives. Thank you.
Thank you, Dr. Liao. First, I wanted to start off with that Consumers Energy really appreciates the partnership and the collaboration that we have with MSU, especially in this space. So I'll kind of get into it, but it's been just essential for us as we've been developing out our RNG or renewable natural gas product line here. So maybe next slide. So just if you're not familiar with Consumers Energy, we are a natural gas and electric utility here in the state of Michigan. And actually, we're the fourth largest combination utility in the United States. So we have a long history of being in Michigan. We were founded back in 1886 and are really just proud about being able to serve Michiganders. So you can kind of see the stats here from our electric and our gas business. But one of the things that's important to us and that we're committed to is really leading the clean energy transformation. And so This year, we're actually exiting coal. So we're shutting down the last of our coal plants this year, which is one of the first major milestones in our clean energy transformation. But then from there, we're looking at net zero methane emissions by 2030. And I'll get into that a little bit more, but our renewable natural gas plays an essential part of how we're going to achieve that net zero by 2030. And then you can see kind of on the slide here as we go forward, net carbon emissions by 2040, and then total net greenhouse gas emissions by 2050. And we do have a step, and I'll get into that too, but a step goal towards that 2050 goal, really around our customers and helping our customers achieve their planet goals by reducing emissions also. So maybe next slide, and I'll get into those goals. So from the natural gas perspective, or the natural gas business that we have really two primary planet goals that we call them planet goals. The first is that net zero by 2030, which we call a scope 1 emissions, right? So those are the emissions that our system generates because of how we operate and deliver natural gas to our customers. The other one is scope 3, which is our customers' emissions, right? So think of large industrial customers, emissions that they may produce, and really helping them to reduce those emissions also. So kind of starting on the left-hand side of your screen here with our net zero goal. We know, from a reduction standpoint, we're really replacing out vintage materials and other equipment that kind of contributes to the overall emissions. And then we're starting up a robust program around advanced methane detection and other technologies on how to really bring our emissions down. But we know that just a natural gas system, by the nature of how it operates, I always kind of sometimes say it has to breathe to just regulate that pressure at different points in time. And so we'll never make it to an actual true zero. We can reduce about the emissions about 80%. And that is what we have plans to do by 2030. But in order to get to net zero, we are looking at what are the options that we have. And we're really looking at renewable natural gas to help offset that 20% of emissions that will stay on the system because of how we, operate, how people work around our system, that type of stuff. And so renewable natural gas for us is going to be the critical point for us to be able to achieve that net zero by 2030. And I'll get into a little bit more, but we're started already down the construction of production sites to help offset that. And so we're looking in total about, you can see about 350,000 cubic feet of gas will be required for us to achieve that. On our customer side, we're also working with our customers on their scope emissions. And so when we look across the board, right, a renewable natural gas is an offering that we're providing. And in fact, we have what we call a voluntary green pricing, where our large industrial customers, to help offset some of their emission or carbon abatement, they can purchase renewable natural gas to help offset some of that. And so as we go forward down the path, we're really looking at building out that renewable natural gas portfolio to be about 4 BCF for our customers over that period of time. And so that for us is kind of our two planet goals, and really why we're focused in on the advantages that anaerobic digestion and renewable natural gas has, not just for our own system and how we want to make sure that we're leading the clean energy transformation, but also for our customers and to be there for them as a solution provider to help achieve their own clean goals. So maybe in the next slide. All right, so why did we decide on RNG as being part of our future? So we do a process where we really look out to see, what the signposts and what the trends are with the industry and the different scenarios that are out there. So what this shows the different scenarios that we see out into the future. Everything from high electrification, where everybody has their furnaces and their water heaters all electrified, to like a balanced scenario type of thing. But you can see in every scenario that we have looked at, biogas really plays an important part of that makeup and that portfolio of how we're going to achieve ensuring that we still have the energy to provide to Michigan to continue to grow our economy and to heat our homes and to power our businesses. It plays an important role in every single one of those scenarios. So when we, take a look back at like the trends and the signposts, for us, it really was kind of a no regrets move for us to kind of start going down that pathway of really starting to build out renewable natural gas so that we're prepared for the future as we go forward. And as I find it also, I want to just kind of point out that even in that highly electrified future, RNG plays a role for fuel for the electric generators, right? To make sure that we're always looking at a clean future for our customers and for Michigan. So maybe next slide. Thank you. Okay. So we ended up really focusing in our efforts on dairy as the RNG source. And the reason why is really it provides the biggest benefit for our customers in the long run. So really the important message to take away from this slide is really around carbon intensity. So the red line indicates the carbon intensity of natural gas. And so any fuel between 0 and natural gas is considered for us a low carbon option. And any fuel that's below 0 is carbon negative. So you can definitely see how RNG from dairy is the winner in this case, right, from an economic standpoint and from a carbon abatement perspective. And so when we looked across all of the different options there, that is how we ended up settling in on RNG from a dairy perspective. I will note too, just from the electricity, you'll see on the MISO grid, right, that is the entire MISO grid. So that does have different technologies and includes coal and other electric generation that is within the grid itself in a larger footprint. All right, next slide. Thank you. And so the other thing too, as I said, we also are looking at our customers, our large customers, right? Those industrial customers that also have decarbonization goals and are looking across the spectrum on what works for them as the best economic choice to help achieve those decarbonization goals. And so in that case, you can also see that gas blended with dairy RNG. And so that is where the customers are purchasing a portion of their gas being a renewable natural gas, right? So they don't have to have 100% of the gas coming to their plants or to their manufacturing site being renewable. They can have it blended in there and it still achieve the decarbonization goals. And so when we look across the different technologies that are available to customers, from a dollar per metric ton of CO2 eliminated, really RNG is it provides the highest benefit. So I'll say, just as you're looking at this slide also, that solar has a carbon intensity of 0. So that's kind of the base level there. The important part with RNG is that it actually has that negative carbon intensity because it's removing the emissions that would have been released into the atmosphere through the cow manure and other sources. So it actually has a negative perspective there. On the far right-hand side is the electricity. And so that's if a customer went fully electrified all of their processes. And that is really based on the footprint of the current electric generation fleet across the nation, right? And so as more and more utilities start converting over to renewable sources, that will start to drop down as you would expect it. But that's kind of the snapshot view right now for our customers. And so in both cases, both from a scope 1 perspective and in a scope 3 perspective, renewable natural gas really provides the best economic benefit for ourselves and for our customers that are looking to decarbonize and really help achieve their planet goals that we have. Next slide. But the cool thing that I think is important too is economics is always going to be an important part of the business profile and why we make decisions. But that RNG has so many more community benefits, and that's important to consumers' energy also, right? We talk about having a triple bottom line being people, planet, and prosperity. And so people includes Michigan It includes, our coworkers, it includes the agricultural community, and all of the other benefits that go into producing energy for this great state. And so when we look across the spectrum, we have the benefits to help our customers achieve their goals and help us lead the clean energy transformation. But RNG also provides a number of important community benefits, right? It's a way to remove some of the existing waste that happens in the farms. We also see reduction of truck traffic, which reduces other emissions going out into the atmosphere. It's a great economic development perspective, and it's a revenue source for the farms that we partner with. And so you can kind of see the list here, but just overall, when we look at the benefits for us, it really hits that full triple bottom line, meaning it's got benefits for our customers and our communities. It has benefits for our planet and leading the clean energy transformation. And at the end of the day, as you saw in the previous slides, it's the least cost option in both scenarios, both from a large customer and from a scope 1 perspective. So that's really like some of the reasons why we ended up really in on renewable natural gas as part of our portfolio. We're looking to take the energy industry here in Michigan. And so we do have a number of sites that are under construction. And so maybe if you want to go to the next slide, I think we got some pictures. Yep. So I just was going to highlight 2 different sites that we have under construction this year. This is our Spring Creek Agri-Energy Center. And the cool thing about this site is it's actually paired up with a large solar farm. So from a renewables perspective, it has both the benefits on the gas side of the business as we build out our renewable natural gas portfolio, and it also has benefits on our electric side of our supply side as we build out our solar portfolio. So this site is actually going to be able to abate about 20,000 tons annually of carbon, with about 100,000 MCF per year production on about 5 acres. Will be the size of the whole site itself as we're building out the digester and buildings. So we're pretty excited about this one. The next one, if you want to switch to the next slide. Yep, that's another location farm that we have being under construction next. And I think Dr. Liao even mentioned it, right? All the other benefits that come. And so in this case, we're actually using the farm will be using the dry fiber and recycling it back into the bedding for the cows. And so it really becomes a circular process for the farm themselves, along with the economic benefits that we'll be purchasing the natural gas from that perspective. So it's beneficial for the farm, it's beneficial for consumers' energy, and our customers at the end of the day. Before I hand it back to Dr. Liao, and we can take any kind of questions that you might have, I really think it's important, the collaboration between the agricultural community and the energy companies, because it's going to be important for us as we go forward from both an economic perspective and an environmental perspective. And the more that we can partner with universities like Michigan State on working on how to continue to make it more efficient and really start bringing down the cost, the more that we're going to be able to bring this to the mainstream and really make it part of, energy portfolio of all the utilities across the country as we all look to really making sure that we're cleaning up and creating that clean energy transformation. So, Dr. Liao?
Yes, thank you, Ms. Bowers, and for your insights on this all energy stuff. Again, both of talks from me and from Ms. Bowers actually come down to this part. So really fostering cross-section collaborations, importance collaboration. So key message is, again, this collaboration can amplify the benefits for all the sectors, rural communities, utility company, and of course, the universities. And this is just, I'm not going to go through all the details, action steps. Actually, from the stakeholders, utility company, and universities, academia, the institution, we need to work together. Really kind of open our minds and let's see and focus on both environment and economic sustainabilities, put solutions together. That's what we do and move things to next steps. So thank you all for attending this webinar. So I think we have a couple of minutes for the questions and answer. Thank you, Mr. Bowers, to participate and give talks for this webinar. Okay.
We actually have a few questions already queued up. I think we've got time. This can be for both Dr. Liao or Holly. How does the RNG future integrate with Michigan's food waste roadmap or framework? And I know we've talked about stakeholders and other partners. So if we don't have the exact answer, how do we like looking at food waste and other producers in the system?
How do you want to start?
Yeah, I'd be happy. I'll start and then I'll hand it over to you. Like I kind of talked about the fact that we're focusing in first on RNG, but even when you saw on that slide of the other options, food waste and other sources for the RNG is going to become a critical part for us because we know there's only so many cows here in Michigan, right? And so we're going to have to start looking at those other sources, especially to make sure we hit our customer needs of the 4 BCF. So for our perspective, like we're starting with the dairy, but we know we're going to have to go into other sources, including food waste.
Yeah, I can add on the one of the top. We have the data, and in the state of Michigan, we have 11 million gallons, 11 million metric tons of the manure, and roughly around 3 to 4 million metric tons of food waste, and mainly is around the cities. So food waste, even though the amount is a bit small, but the energy content is very, very high. And as so Holly just mentioned, actually mix them together, right, can increase the energy production. And also, if you look at distribution perspectives, and farms even distribute the kind of southern part of Michigan with the population density high, and food waste is available in that area too. So the cow digest is a solution to address that. So.
Well, I think this is a good follow-up. Our last question of the session is, what do you see as the first steps in rolling this type of technology or this energy process out into the communities across Michigan, the United States?
I'll start. Honestly, the first step, I think, is relationships between the energy companies and the agricultural community. Like that has been really important for us as kind of the first step of knowing that we're here, like for the long run, right? We have a long history of being in Michigan, and many other utilities in their states have a long history. But I think that's important because we're not coming in and then leaving, right? And so for me, the very first step is really creating that relationship. And then from there, I think we have to get more comfortable with where we're going from a renewable perspective, and that there's going to be a blend overall between our fossil fuels and our renewable energy sources as we make that full transition.
Yeah, just to add on to what the Mr. Bauer just mentioned, energy is chiming in the point because you need to have the start point to put these the sustainabilities into that rural setup. So with energy as at this moment, because energy regulated, they have the price tax on that. But once the revenue coming back from the energy and these partnerships form established, actually as mentioned in our presentations, we can expand it more on other revenue streams. The two kind of benefit again, it's not only just rural communities, actually win-win-win situations, energy companies and the rural community, even third parties, the companies or the private sectors, they can benefit. Again, as mentioned, efficiency, right? Once the efficiency increase, it's not only just a carbon, nitrogen and phosphorus. Those are very valuable, the products. I know consumers' energy is part not in that corner talk about those things, but energy is a start point to push things, that moving towards that direction. So that's something.
Can I add one more thing? One of the things that we talk a lot about is the LCOE, or the levelized cost of energy. And so like renewable natural gas is going to be competing with solar and wind and other renewable sources. And so I do think the efficiencies, the cost of bringing down the cost of like construction and operations is going to be kind of a critical component too, because there's going to be that competition. Right? It's a great thing to have with competition for renewables, but it's going to be an important part to really bring down that LCOE that we have overall.
Okay. Thank you all. Thank you, Ms. Bowers, to participate, and thank you everybody
Thank you.
in this webinar. Thank you. Bye-bye.